The Sun recently unleashed one of its most powerful eruptions of this solar cycle. A massive blast of superheated plasma shooting into space at incredible speed. It was so intense that the shockwave actually reached Venus, our neighboring planet, that alone made scientists pause and ask an unsettling question. Could Earth be next? If your internet has been working fine and there haven't been widespread power outages lately, then you already know the answer. Earth was not in the direct path of this eruption. The event occurred on October 21, 2025, and if the blast had been headed our way, its effects would have arrived within just a few days. What we're talking about here are coronal mass ejections, or CMEs. These happen when the Sun violently ejects huge clouds of superheated plasma from its outer atmosphere. Plasma is a charged form of matter made of energized particles, and it's what the Sun is mostly made of. These eruptions happen when tangled magnetic field lines suddenly snap and reconnect, releasing enormous energy in the process. When that happens, billions of tons of solar material can be launched into space, forming a fast-moving shock wave. These shock fronts can accelerate particles to extreme speeds and create radiation storms if a planet happens to be in the path. The results can be serious. The tricky part is that CMEs are unpredictable. They don't all travel at the same speed or direction. Some crawl through space, while the fastest ones race at millions of kilometers per hour if aimed directly at Earth. A CME can arrive in as little as 15 hours. Slower ones may take 1 to 5 days. Either way, this recent eruption already passed its window, so Earth was never in danger. And even if it had struck us, it wouldn't mean the end of the world. Strong solar storms can disrupt satellites, interfere with GPS and radio signals, and even cause power outages. But they are not planet-destroying events. Humanity has experienced many of them before. Venus, however, is a very different story. Solar eruptions are one of the reasons Venus became such an extreme and hostile world. To understand why, we need to look at what made this particular eruption so powerful. The blast originated from a massive and chaotic sunspot region known as active region 4000 to 146. This area was highly unstable and responsible for multiple solar outbursts. The eruption occurred just as this region rotated out of view from Earth, on the far side of the Sun. Because it happened out of sight, most Earth-facing instruments couldn't see it directly. Fortunately, a specialized NOAA satellite equipped with a coronagraph was able to capture the event. This instrument blocks the Sun's bright surface so scientists can observe the faint plasma clouds expanding into space. It orbits high above Earth, about 22,000 miles up, giving it a perfect vantage point. Measurements showed that this CME was traveling at roughly 820 kilometers per second, though early radio signals suggested speeds closer to 1,500 kilometers per second. That places it among the fastest solar eruptions observed in recent years. For comparison, one of the strongest events in modern history happened in 2017 during an X-class solar flare, rated around X8. X-class flares are the most powerful category, and each number increase represents a stronger burst. That 2017 event disrupted radio communications on Earth for a short time. Mars, however, took a much bigger hit. When that earlier eruption reached Mars, it caused noticeable heating in the planet's upper atmosphere. The thermosphere and ionosphere began interacting more strongly than usual, which led to oxygen escaping into space at an accelerated rate. In simple terms, Mars temporarily lost part of its atmosphere. This brings us back to the recent eruption and why Venus was the real target this time. Venus happened to be directly in the path of the solar blast. When the wave of charged particles reached the planet, it slammed straight into its atmosphere. And unlike Earth, Venus has almost no global magnetic field to protect it. Earth is shielded by a powerful magnetic bubble called the magnetosphere. When solar particles reach it, most are deflected around the planet. A small portion still enters the upper atmosphere, producing auroras and occasional disruptions to technology. But the planet itself remains protected. Venus doesn't have that shield. Without a strong magnetic field, solar particles crash directly into its atmosphere. Over time, this strips away atmospheric gases, molecule by molecule. This process has played a major role in turning Venus into the extreme world we see today. A clear example happened on December 19, 2006. A relatively slow solar eruption reached Venus days later, and still managed to tear large amounts of oxygen from its atmosphere, sending it drifting into space. Events like this help explain why Venus became so hostile. Its surface temperature is hot enough to melt lead, its atmospheric pressure is crushing, and spacecraft survive there for only a couple of hours at best. Continuous exposure to solar storms without magnetic protection, likely helped push the planet toward this runaway greenhouse state. By studying how solar eruptions affect Venus and Mars, scientists gained valuable insight into how planetary atmospheres evolve and what conditions are necessary for life to survive elsewhere in the universe. Understanding magnetic shields may be one of the keys to finding habitable worlds beyond our solar system. And that's the story behind the powerful solar blast, why Earth stayed safe, and why Venus continues to suffer the consequences. If this video sparked your curiosity, don't forget to like it and share it with others who love space science.